Now, the type of rocks. What are rocks? Rocks is going to consist of minerals. South, the more rocks are made up, it is plateau. In the north, it is the soil which is derived from the rocks. Minerals are aggregated in these rocks. Agglomeration of the minerals. So, rock is nothing but we have minerals in the rock. So, we say that rock is nothing but the agglomeration. So, rock is a agglomeration of minerals. Rocks contain minerals. What is the difference between the rock and the minerals? Minerals are made up of elements in the purest form, inorganic in nature. Inorganic in the sense no carbon is present. For example, the minerals include iron, gold, oxygen, nitrogen. Multiple elements are clubbed. We call the mineral of the iron is ferrous oxide, right? So minerals are the elements in the purest form. The elements are in the purest form. Rocks are nothing but the agglomeration of these minerals. So we have what is called as a rocks. Rocks are agglomeration. It is going to consist of the agglomeration is it is going to consist of minerals. So agglomeration of the minerals. First we have the elements. Minerals, rocks. Minerals are solid inorganic substances which are occurring naturally. Minerals are first they are solid and second is they are inorganic. The first is they are solid and the second is they are inorganic which occur naturally, right? They are aggregates of the minerals is what we have the rocks. A rock has no definite chemical composition. There is no chemical composition in a rock, whereas the minerals have a definite chemical composition. So this must come here. So the minerals have a definite chemical composition, whereas the rocks do not have a definite chemical composition. Right. So are the solid inorganic substances which are occurring naturally. Solid inorganic substances, these are aggregates of the minerals. Minerals are going to have a definite chemical composition, whereas rocks are going, there is no definite chemical composition. Minerals are organized to form the rocks, whereas elements are organized to form compounds which are known as the minerals. An element is the purest substance. We have four over here. We are going to have four chief mineral groups are silicates, carbonates, sulfides, metallic minerals. The three chief rocks are igneous rock, metamorphic rock and sedimentary rock. Whereas there are four mineral groups. It is going to be first is metals, right? So metallic. The second one is silicon, right? Silicates, silicates, and then carbonates. All the metals, silica, carbonates, and then we have sulfides. So MSCS. Silicates, metallic, and then we have the silicates. Metals, silicates, carbonates, and sulfides. Whereas the types of the rocks are divided into igneous rocks, sedimentary rock, and metamorphic rock. The minerals are divided into, we have the minerals are divided into M for metallic and MS. So the minerals include iron, silica, magnesium, nickel, calcium, potassium, sodium are abundant minerals on the earth. Now we already know that IOSMN, iron, oxygen, silicate, magnesium, nickel are the abundant elements on the earth. Now for the rocks we need to know different kinds of the rocks is basalt, granite, sandstone, slate, quartz. So we'll be having the basalt. And then we have the granite. So basalt, granite, sandstone. Then we have the sandstone. So basalt, granite, and then we have the sandstone, slate, and then we have the quartz. So slate and then we'll be having the quartz. Basalt, granite, sandstone, slate, and then we have the quartz. Right. So basalt, granite, sandstone, slate, quartz are some of the important types of rocks. Rocks are naturally occurring agglomeration of the mineral particles from the any naturally occurring agglomeration of the mineral particles form the rocks. The rocks contains minerals. The types of the rocks are igneous rocks, metamorphic rocks, and then we have the sedimentary rocks. Igneous rocks. Igneous means fire. The rocks formed from the fire are igneous rocks. So igneous is going to be the fire. The rocks formed from the fire. Right. So igneous rocks are fire. The rocks formed from the fire are igneous rocks. Now they are formed from the magma. Magma is nothing but the molten rock material. It cools down. Now we have two types of igneous rocks: extrusive igneous rocks and intrusive igneous rocks. Extrusive igneous rocks are outside or above the surface is what we have the extrusive igneous rocks, and intrusive igneous rocks are below the surface, or they are also called as the plutonic rocks. Now, they are absence of any layers. Metamorphic rocks have layers and sedimentary rocks has layers. They do not have layers. The igneous rocks do not have layer, and the types of igneous rocks are intrusive igneous rocks, and then we have the extrusive igneous rocks. Now the types of rocks include the igneous rocks, metamorphic rocks, and then sedimentary rocks. Igneous rocks, igneous means fire. They are formed from the magma. Magma is nothing but a molten rock material which is cooling down. Extrusive igneous rocks are outside or above the surface, and intrusive igneous rocks are below the surface. Then we have the plutonic rocks. Then absence of the layers. Metamorphic rocks may have layers, and sedimentary rocks also have layers. Now silica content, if it is more than 66%, it is acidic rock. Therefore we call it as a felsic rock. Rhyolite granite is a felsic rock. Now silica content and then acidic or basic. Right. Silica content. If it is silica content is greater, it is called as acidic. If there is more amount of silica, that is more than 66% of the silica. If it is greater than 66%, usually greater than 50% is half, right? But here we are taking one third, 66%. Right. Two third is 66%. One third is 33%. So two third, you divide you measure the acidic content. If the acidic content must be greater than two-third, it is called as acidic rock. If it is less than, for basic rocks, acidic content is taken as half. If it is less than 52%, it is called as basic rocks, or also called as mafic rocks. So acidic rocks are also called as felsic rocks. Basic rocks are also called as a mafic rocks. So acidic rocks are also called as a felsic rocks. Felsic rocks. Then we have the basic rocks are also called as the mafic rocks. So acidic rocks, and then we have the basic rocks. Acidic rocks are also called as a felsic rock, and basic rocks are also called as the mafic rocks. So the felsic rocks example is the rhyolite and granite. Granite cool downs below the surface. Then we have to do quarrying or mining to obtain granite. Right, because granite is cooling down below the surface. So quarrying or mining is required. Basic mafic is nothing but the basic rock. It is basalt or gabbro as an example. And for the acidic rock, we have rhyolite and granite as an example. Granite cools down below the surface, therefore we have to do quarrying or mining is required for obtaining the granite. Felsic rock is rhyolite and granite, and basic rock we have two examples as gabbro and basalt. Now intrusive igneous rocks. We have seen the types of the igneous rocks like intrusive igneous rocks and extrusive igneous rocks, right? So the intrusive igneous rocks, and then we have the extrusive igneous rocks. In the intrusive and extrusive, we are going for other classification based on the silica content, and it is called as a acidic. Acidic is called as filsic. Acidic is called as a filsic, and basic is called as a mafic. So acidic is called as a filsic and basic is called as a mafic. So acidic rock is also called as a rhyolite. Examples of the acidic or the filsic rock is rhyolite, and we also have the granite. So rhyolite, and then we also have the granite, right? So rhyolite, and then we have the granite. So two types of acidic rocks are rhyolite, and then we have the granite. The two types of the acidic rocks. Here we have the types of the acidic rocks as rhyolite. So the types of the acidic rock as the rhyolite, and then we have it as the granite. So rhyolite, and then we'll be having it as a granite. The type of the basic rocks is gabbro and basalt. Gabbro and basalt. Now here we are going, granite is intrusive igneous rocks, right? Granite is an example of the intrusive igneous rock. Basalt is found around the oceanic floor when the magma erects out of the ocean floor. So basalt is an extrusive igneous rock. For example of the extrusive igneous rock is basalt. So basalt is an example of extrusive igneous rock because it is found in the oceanic floor due to the eruption of the magma outside the oceanic floor. Now gabbro is an intrusive mafic rock. Gabbro, right? Now we have extrusive rocks because of the volcanic eruption. Porphyry, pyroclast, rapid cooling down, and they are brittle, they are very small, they are brittle, very small particles. Extrusive igneous rocks, they are glossy in appearance, so because they are undergoing a rapid cooling, whereas intrusive igneous rocks, they undergo slow cooling, therefore the crystals are stronger. The extrusive igneous rocks, maybe having the extrusive igneous rocks are going for a rapid cooling down. So the extrusive igneous rocks are going for a rapid cooling down, therefore they are brittle. They are easily broken up. The intrusive igneous rocks are slow rate of cooling. Their crystals are stronger. This extrusive igneous rock is having a glossy appearance. Igneous rocks, they are primary rocks directly formed from the magma. A rock which is formed from the magma. They are formed by the solidification and crystallization. So, what is the process through which they form? Solidification. The process through which they form are solidification and crystallization. The process through which the igneous rocks are formed are solidification, and then we have the crystallization of the molten material of magma. They are called as primary rocks. So we call these rocks as the primary rocks. These rocks are also called as the primary rocks, right? There are two types of igneous rocks. We know that intrusive igneous rocks and extrusive igneous rocks. They are formed from the cooling of the magma inside the earth. This intrusive igneous rock is the cooling of the magma inside the earth. We have the granite and gabbro and diorite. Gabbro is a mafic rock, granite is a felsic rock, diorite is an example. Extrusive igneous rock is basalt and andesite. Andesite is an acidic rock, right? Andesite and basalt is a basic rock or a mafic rock, and also the gabbro. Here we say that extrusive igneous rocks are formed from cooling of the magma above the earth's surface. They can also be classified into acidic or filsic when the silica percentage is greater than 66%. Example is granite. Or mafic when the silica percent is less than 52%. Example is the gabbro or basalt. So the continental crust is mainly made up of acidic rocks. The continental crust is made up of the acidic rocks where the silica content is more. The oceanic crust is made up of the basic rocks whereas silica content is less. Usually in the continents we have the silica content is more, and in the ocean rocks the silica content is less. So we say that the continental crust is mainly made up of the acidic rocks, where the silica content is more, and the oceanic crust is mainly made up of the basic rocks, where the silica content is less. The silica content is between 52 to 66. Intermediary rock is what we have. The andesite is an intermediary rock, right? Sedimentary rocks, the sediments, tiny particles, minute tiny particles which are derived out of the rocks. Rocks are external forces, tiny particles, they are undergoing the external forces, therefore they are becoming rocks. External force acting at the sediment. Sunlight, wind, rainfall is very important for a rock to weather. Because of the sunlight, weathering takes place because of the sunlight, wind, and the rainfall. We have a rock. Weathering of this rock is going to take place because of the sunlight, wind, and then we have the rainfall. Weathering of this rock is going to take place. Then there is a formation of the sediments, the compaction or hardening of the sediments. So we have the compaction or we have the hardening of the sediments. Compaction or the hardening of the sediments. The sediments are derived from the igneous rocks. Thousands of years of weathering. Another sedimentary rock is metamorphic rock. Sorry, from the metamorphic rock also sedimentary rock is being formed. Sediments are derived from the igneous rock by thousands of years of weathering for thousands of years, and even from the metamorphic rock, and even from another sedimentary rock, a sedimentary rock can be formed. The steps is a huge massive rock is subjected to weathering. The weathering is due to the sunlight. The weathering is due to the sunlight, and we also have the rain and wind are the reasons for the weathering, breaking down into the fragments, and they are transportation. Lithification is the formation of the lithi is the rocks, right? So lithification. Now after lithification, compaction and cementation. Lithification becomes hard converts to a rock, so it is becoming hard is what we call it as lithification, when it is becoming hard, right? Once lithification is being done, we are going for the compaction, and after the compaction we go for the cementation, right? In the lithification, deposits are becoming hard and it converts to a rock, and lithi means rock. In the compaction, compresses and it becomes hard. Cementation is when the small pores, we have small pores. The small pores are filled with natural cementing agents, or else it is brittle, it will break easily. Lithification is the overall process of becoming the rock. Example is a sandstone, limestone, coal, and then we have the chalk. Sedimentary rocks are formed by solidification of the sediments of the original igneous or metamorphic rocks, or even one sedimentary rock may also lead to the formation of another sedimentary rock. The stages in the formation of the sedimentary rocks are weathering, the in situ breakdown of the original rocks, and transportation of the sediments. Deposition of the sediments and then lithification involves the conversion of the loose sediments into hard rock. Compaction is when the sediments are squeezed by the weight of the overlying layers. Cementation is binding, involves binding together of the compacted sediments by natural cementing process. So we go for lithification, compaction, and cementation. Lithification, compaction, and then we have the cementation. Involves the binding together of compacted sediments by natural cementing materials. Sedimentary rocks are formed in different layers or the strata, bodies buried and preserved as a fossils. Sedimentary rocks, unlike the igneous and the metamorphic rocks, contain a large quantity of the fossil evidence: sandstone, limestone, clay, chalk, coal, and gypsum. Metamorphism is a change in the form, is what we call it as a metamorphism. Pressure, volume, and temperature. Change in the form due to the PVT is pressure, volume, and temperature. Metamorphic rock changes the form either because of the change in the temperature or because of the change in the pressure conditions. So metamorphic rocks are going to change its form. We say that the metamorphic rocks are going to change its form. Metamorphism is a change in the form due to the pressure, volume, and then we have the temperature. So, pressure, volume, and then we have the temperature. Metamorphic rocks change the forms either because of the change in the temperature. So, we say that there is a change in the temperature, or because of the change in the pressure conditions. Or because of the change in the pressure conditions. There is a change in the temperature, or because of the change in the pressure conditions. Either the physical or the chemical characteristics or even the composition change leading to the metamorphic rock. Pressure conditions induces the change, dynamic metamorphism. When the temperature, it is thermal metamorphism. When both pressure and temperature are inducing the changes, it is called thermodynamic metamorphism. So in the metamorphic rock, we say that the pressure and the temperature are causing the changes to the rock. Metamorphism means a change in the one form to another, right? This change is because of the pressure, volume, and temperature changes. So, pressure, volume, and temperature changes. Metamorphism is a change in the form. The metamorphic rocks is the rocks changes the form either because of the change in the temperature or because of the change in the pressure conditions. Either the physical or chemical characteristics or even composition change leading to the metamorphic rock. Pressure conditions, dynamic metamorphism. Temperature, thermal metamorphism. When both are acting, we call it as a thermodynamic metamorphism. What really happens? Reorientation of the crystals inside the rock or recrystallization. Over here, we call it as recrystallization. Either the physical or the chemical changes or even the composition change due to the metamorphic rock. The pressure condition induces the change, dynamic metamorphism. See, we say that there is a physical or chemical characteristic changes, right? Therefore, reorientation of the crystals inside the rock or recrystallization. In deformed rocks, we may be having the igneous, sedimentary to metamorphic, or even metamorphic to metamorphic. The two important processes are foliation and lineation. Foliation is nothing but the pressure on the top and the bottom is foliation. Pressure on the top and the bottom is what we have the foliation. So pressure is on the top and the bottom is foliation. It leads to the flattening. This is the original rocks. On all sides it is similar. But when pressure is applied on the top and the bottom, it causes the rocks to elongate, flattened foliation, and when it is stretched it's called as lineation. So stretching of the rocks is lineation, flattened is foliation, and stretching of the rocks is lineation. Arranged in line stretches, foliation, and then we have the lineation. Banding, foliation leads to banding and lineation leads to lining. Mineral arrangements in a series of band of paints, mineral arrangement in a linear manner. Metamorphic rocks. Metamorphic rocks involve changes in one form to the another. Example, granite is an igneous rock which is changed into gneiss and it is foliated. It is pressed in top to bottom, right? Splits into thin pieces. Sandstone is sedimentary rocks and sandstone becomes quartzite. Quartzite is a metamorphic rock. It is non-foliated. So we have to go for the sandstone. Coal is a sedimentary rock, it becomes diamond, is a metamorphic rock. Clay is a sedimentary rock, it becomes slate. Slate is again a sedimentary rock, right? Shale is a sedimentary rock, it becomes schist. Limestone becomes marble. So limestone is becoming marble, shale is becoming schist. Sandstone is becoming quartzite. So sandstone is becoming the quartzite. It is very important to know that the sandstone is becoming the quartzite. We say that the sandstone has become the quartzite and shale is becoming schist, limestone is becoming the marble. Magma is igneous rock or the igneous rocks nearby area of the sedimentary rocks undergoes recrystallization due to the magma, limestone to the marble. First we have the difference between the foliation and sedimentary layering. Foliation is caused by fire and stress, while layering is caused by embedding of coarse and fine deposits or sediments. Foliation is due to the alteration of the minerals from the heat and the pressure, while layering is caused by seasonal changes. Contact metamorphism and regional metamorphism. Two types of thermal metamorphism is contact metamorphism. The rocks come into contact with the hot intruding magma, right, and lava, and the rock materials recrystallize upon high temperature. This is because of the temperature. We are going to say we have two different types of heat metamorphism. One is called as a contact metamorphism and the other is called as we can say it as the um, regional metamorphism. So contact metamorphism and then we have the regional metamorphism. Contact metamorphism and regional metamorphism. There are two types of thermal metamorphism. The rocks come into contact with the hot magma and lava, and the rock materials is going to recrystallize under high temperatures. Right. The rocks come into contact with the hot intruding magma. They are recrystallizing is contact metamorphism. The rocks experiences recrystallization due to deformation by tectonic shearing together with high temperature and pressure or both is regional metamorphism. Now rock cycle, the intrusive rock upon burial it becomes a metamorphic rocks. Metamorphic rocks upon uplift and weathering it becomes a sedimentary rocks. Right. Extrusive rock if it is an uplift igneous rock it is going to outcrop, either it is going to become sedimentary rock or it can also become a metamorphic rock. In intrusive igneous rock it is becoming an extrusive igneous rock. Sedimentary rock can become metamorphic rock due to deep burial and heat and pressure, compaction, cementation, and metamorphic rock we have heat and pressure. So we say that the sedimentary rock, the sedimentary rock is going to have compaction and cementation. The sedimentary rock is going to have the compaction and cementation and metamorphic rock. So we'll be having the metamorphic rock is going to have the heat and then we have the pressure. So heat and then we have the pressure. So sedimentary rock is going to have the compaction and cementation, whereas metamorphic rock is going to have the heat and then we have the burial. Heat and then the pressure. Sedimentary rocks and then we have the metamorphic rocks. So magma melts and it is going to cause the cool down. Magma cooling will be having the intrusive extrusive uplift. Burial rocks comes up. Various forces interior of the earth pushes. Exposed rock is an outcrop and it is undergoing weathering. Sediments are burial. Sedimentary rocks due to heat and pressure it becomes metamorphic rock. When it is further heating it becomes magma and igneous rocks. Regional metamorphism is anticline syncline, right? Anticline is elevated, syncline is depressed. Pressure is maximum, pressure fold. We'll be having the lineation and foliation. Contact metamorphism is when they are coming in contact with the lava. Contact metamorphism, magma of the limestone to marble, right? Now, classification of the rocks. The chemical classification of the rocks in the sedimentary itself is limestone, dolostone, evaporates. Clastic conglomerate, breccia, sandstone, siltstone, mudstone, shale. Biological is cold and shut. Igneous, intrusive, extrusive, and we also have felsic, mafic. Metamorphic, foliated, lineated. Gneiss is a foliated, which means different layers, lighter and darker material. Schist is a metamorphic rock. Shale or mudstone from the shale or the mudstone. To become a schist, a shale must be metamorphosized into the steps through shale and then through phyllite. If schist is metamorphosized further, it becomes gneiss.